All right, let's get going on this. This is the last homework assignment, which is homework number 11 for chapter 3. Number 127. Solve the equations below by first changing each equation into a simpler equivalent equation and check your solutions, right? So notice on A that these numbers are pretty big, which means that you can probably do something to make them smaller. I would suggest count how many zeros. The first term has 3 zeros, 3 zeros, and 4 zeros, but in reality, that last piece it's a 10 with 3 zeros, just like the first two. Right? So I think they all have 3 zeros in common. So I'm going to go ahead and say we can divide both sides by 1,000 or 3 zeros. Oops, little lag. Okay. So by dividing by 1,000, we actually have, excuse me, we actually have 3,000 x divided by 1,000, which comes out to be 3x. Okay. And by dividing by 1,000, we have 2,000 divided by 1,000, which is minus 2. And that's going to equal, then we have 10,000 divided by 1,000, and that makes 10. So this is a much simpler equation, and the rest of this, just gotta do inverse operation of adding 2 to both sides. And we will have 3x equals 12, because that's what 10 plus 2 is. And then we're going to divide it by 3, and we get x equals 12 divided by 3 is 4. Okay, because these cancel, and that's what you're left with. Okay, part B. Notice all of these fractions. They have a 2, a 5, and a 10. You can do them each individually and separately, but if you think about it, you can multiply both sides by 2, and you can multiply both sides by 5. So when you do both by 2 and by 5, you're actually doing it by 10, and you also need to multiply both sides by 10. So in its entirety, you can multiply both sides by 10. Okay. So 10 times 3/10 just makes 3 plus, and then 10 times 2x over 5, and if I write it down like that, so 10 times 2x over 5. Okay, and what you notice is that the 10 and the 5 could cancel, right? 5 goes into 10 2 times, and 5 goes into 5 1 time. So you really have, for the second term, 2 times 2x divided by 1. Okay, or just 4x. And that's going to equal, and then this last piece is going to be 10 times 2, and you can cross cancel or simplify 2 and 10. You can divide them both by 2. So 2 divided by 2 is 1. 10 divided by 2 is 5. So your answer is 1 times 5 over 1. So 1 times 5 is just 5. Divided by 1, it's just 5. Okay, and that's your simpler equivalent equation. And then now you just gotta combine or solve for x. So we're gonna go ahead and do inverse operation of minus 3. So we have 4x equals 5 minus 3 is 2. And then you're going to go ahead and inverse operation divided by 4. And some of you guys are going to say 2 because 4 divided by 2 is 2. But it's actually 2 divided by 4. So you use the top number first. So 2 divided by 4. Right, so your x equals 1/2. That's your answer. Okay. We're going to go ahead and plug these in to check our solution to make sure that they are correct. So in order to check, you got to use your answer, the ones that we put in the boxes, and plug them into the original equation. So this first one here, if I plug in 4 into the x right there, put a 4 in there. Okay, so that makes 3,000 times 4, which is 12,000, minus 2,000. And does that equal 10,000? Right, and 12,000 minus 2,000, that is indeed 10,000. So that's check. That works out. Okay, second one, we're going to go ahead and plug in 1/2 into the fraction. Okay, I'm going to use that, and I'm going to use that to check. So I'm going to make a little bit of space for myself. So you plug in 1/2 in here. So we have 3/10 plus, and if I put 1/2 in for x, I'll get 2 times a half. Or if you think about it, what is a half of 2? Right, a half of 2 is 1, and then there's a 5 on the bottom, and that's equal to 1/2. Okay, following the equation. Now work this out. In order to add these fractions together, you need a common denominator at the bottom. So if I go, you know what, I need to multiply this by 2, so that way I get weighted to 10, right? And I don't need to do anything to the 10. I can say 1, but that doesn't change anything, so I'm not even going to bother with that. So you will have 3/10 plus, and then 2 times 1 is 2, and 5 times 2 is 10. And that should equal 1/2. Right? And 3 plus 2, let me actually make a little bit more space. So 3 plus 2 is 5/10, and that should equal 1/2. And 5/10, if I divide them each by 5, meaning if I want to simplify them, 5 divided by 5 is 1, 10 divided by 5 is 2, so you get 1/2 equals 1/2. And the answer of x equals 1/2 works down here. So that checks out as well. Okay, that's number 127. Number 129. Plot triangle ABC on the graph. Okay, so ABC. A is 6, 3. So 1, 2, 3, 4, 5, 6, and 1, 2, 3. So that's point A. B is 2, 1. So 2 and 1. That's what B is. And C is 5 and 7. So that's triangle A, B, C. Okay, I'm going to move B just over a little bit. Okay. Now, part A says you're going to take this triangle ABC. Here, I'll move it down. And you're going to go ahead and rotate this around the origin 180 degrees. Okay. So if I rotate this around the origin 180 degrees. So let's say point A. So point A would be 1. Excuse me, let me get a different color. Point A would be 1, 2, 3, 4, 5, 6, and then up 1, up 2, up 3. Right, so 180 degrees would be to the left 6, 1, 2, 3, 4, 5, 6, and then down 3, 1, 2, 3. And that would be our point A prime. Okay, point B is 1, 2 to the right and up 1. So 180 degrees would be exactly the opposite. To the left 2, 1, 2, and then down 1. And that would be our point B. Oops. The point C is going to be 1, 2, 3, 4, 5 to the right, and then up 1, 2, 3, 4, 5, 6, 7. Okay, 180 degrees rotation would be to the left 5 and to the bottom 7. So 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 6, 7. So that's where point C prime would sit. Okay, and that is my new triangle A prime, B prime, C prime, which has been rotated 180 degrees. Okay, the coordinates of A are -6, -3. Okay, which is just exactly the opposite of 6, 3. The coordinates of B B prime are -2, -1, which is exactly the opposite of 2, 1. And coordinate C prime is going to be -5, -7, which is exactly the opposite of 5, 7. All right. Okay, so that's part A. Get that down? I'm going to erase it. So pause it or rewind a little bit. Okay, part B. This time triangle ABC is rotated 180 degrees about point C to form A double prime, B double prime, and C double prime. Name the coordinates of B double prime. And so from here, okay, so the direction is we're going to take this as our point of rotation and we're going to rotate it around. So that means that this triangle is going to rotate around point C, and 180 degrees just means it's exactly the opposite. So let's start with point C, and then let's count what's the change in Y and change in X, or let's make a little hook for it. So let's just say from C, I'm going to go and do 1 to the left, 2 to the left, 3 to the left, and then 1 down, 2 down, 3 down, 4 down, 5 down, 6 down. Okay, so it was 3 to the left, so it was -3, and that'll be -6. Okay, that's how I get to B. But if I do this 180 degrees, then my new point B is gonna be, instead of 3 to the left, I'm gonna go 3 to the right. So 1, 2, 3 to the right, and then I'm gonna go up 6. So it's exactly the opposite. So 1, 2, 3, 4, 5, 6. Okay. Now this one is a little bit it's a little bit off, but it's okay. So I know that my new point, this is my point, B double prime. Okay. So I know that up to this point right here, I'm going to use, let's go purple. Right. So up to point C, so it'd be 1, 2, 3, 4, 5. I have to go 3 more. So 6, 7, 8. Right. So I know this point B double prime is going to have a coordinate of X value is +8. Now I'm going to count how much does it take to go up. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's about as much as I can go on my graph. But I know I have 3 more marks after that. So 10, 11, 12, 13. So that would be +13. So my new coordinate of B double prime, 8, 13. Okay, and that's if it's rotated 180 degrees around point C. Okay, and that's all using everything that I've done. Okay, backside. Determine the value of X that will make each equation true. All right, and this is what we learned in class today. So if you notice, the base is base 2 and base 2. So that means that they're exactly the same and they are supposedly equal because that's what the equation says. So if they're both base 2, then that means that both of their exponent are going to be equal or equivalent as well. So in this case, we're going to write our exponent as x equals 3 or 3 equals x and solve for x. And what do you know? It's already done. So there, it's solved for x. Okay, this next one. We have the base of x and a base of 5. And they're supposedly equal. Remember that. They're supposedly the same. So, and then we notice that the the power 3 is the same, and which they are. So therefore, these are equivalent in the ways that the exponent is the same. That means that the base is also the same, or the base, meaning that the x is going to have to equal the 5. And in this case, solve it, and it is solved. Okay, the last one. We have the base is 2 and 2, and then the exponent is 7 and 2x plus 1. And they're supposedly the same. So since the base is the same, then that means that the exponent of 7 is supposedly the same as 2x plus 1. In this case, I got to solve it because it's not quite done being solved. So I have to do the inverse operation. So it's negative, so minus 1 from both sides. And I get 2x on the right-hand side is equal to 6 on the left-hand side. And I'm going to keep going, and I'm going to go ahead and do another inverse operation of multiplication is division. So again, these will simplify out to be a 1, and I get my answer of x equals, and then 6 divided by 2 is 3, and that's my final answer. Okay, that's a wrap, guys.